Hi, this is Ms. Claywell. We are going to be going over skill 16, probability of multiple events. So that means more than one event happening at the same time. When we say the probability of A and B happening, we're going to think of this in terms of Venn diagrams. When I say A and B, that means that both can happen at the same time. So I'm referring to the middle section of a Venn diagram. When I say we can do A or B, this means we can do all of A all of B, so inadvertently both is covered because it's in the middle. So this is either A, either B, or both. When we use this language of not something, so if it's not A, we can think of this two different ways. That means anything outside of A's circle. So it can be all of B. Also, we'll practice more of this later, but anything outside of the Venn diagram or data points that aren't A or B would be not A. We're going to talk about the difference between independent and dependent events now. When I tell you someone or something is like dependent, that means it is affected, they affect each other. So if you're, the weather, what you wear depends on the weather, means they affect each other. So the occurrence the occurrence of one event affects how the second event occurs. Independent means that they don't affect each other, so the occurrence of one event doesn't affect event can occur. So we're going to take a second now and read these two examples and decide if they affect each other. So I'm rolling a dice and then I have a spinner. Does what I roll on the dice affect what I spin on the spinner? It does not. So these are independent because the events don't affect each other. So my example B is saying I pick a flashcard and then I pick another flashcard. So I'm thinking, does my first flashcard affect what I get from my second flashcard? And it does, because I can't, once I pick that card, I can't pick it again, so it does affect my second flashcard. After my first draw, I don't have the same options my second draw, so it does affect it. supposed to be dependent. Picking the first flashcard affects the possible outcomes of the second card. So now we're going to get into probability of independent events. So notice this only works for independent events. So if A and B are independent events, then probability of A and B equals the probability of A times the probability of B. So for example, we're at a picnic and we have diet drinks and regular drinks, and we have fat-free chips and regular chips. It wants to know if you grab a drink and chips without looking, what's the probability that it's diet drink and fat-free chips. So I'm going to do that probability of diet drink times probability of fat-free chips. So I have 10 diet drinks out of 15 and 15 drinks total, and I have 8 fat-free chips out of 20. If I simplify this, I get 2/3 times 2/5. So I get 4/20. Not 20, my bad. 4/15. So if they're independent events, then we just can multiply probability of A times probability of B. So moving on to mutually exclusive events. If something's mutually exclusive or something's exclusive, think of it like the events can't happen at the same time. So for example, I can't be at home and at the grocery store at the same time. So we're going to think through these events. As you roll a standard dice, we're going to see if these are mutually exclusive. So can I roll a 2 and a 3 at the same time if I roll a dice? So these are mutually. So this is yes, mutually exclusive. You can't roll a 2 and a 3 at the same time. The next one it wants us to think about is, can I roll an even number and a multiple of 3 at the same time. So let's think of the even numbers, or let's say even. 2, 4, 6. Multiples of 3 that are on our dice are 3 and 6. So if I roll a 6, so these are not mutually, they can happen at the same time, so it's not mutually exclusive. If rolled a 6 would have an even number, and multiple of 3 at the same time. Okay, now we're going to talk about the probability of A or B. So if I think of what on a Venn diagram, what that looks like, remember we decided that A or B means any part of it. So I'm going to start with the probability of A plus the probability of B. And if I think of that on a Venn diagram, I've done all of my A and all of my B, but notice I've double counted my middle section. So in order to not double count my middle section, I need to subtract the probability of A and B. So these two examples, at a high school, students can take one foreign language. About 37% of students take Spanish, 15% take French. What's the probability of a student takes Spanish or French? So we're going to have probability of Spanish or French going to equal the probability of Spanish plus the probability of French minus the probability of Spanish and French. So 37% of the students take Spanish, 15% of the students take French. Now when you think about what is the probability of taking both, our key word here is we can only take one foreign language each term. So there's a 0% probability of them taking both. So my probability of taking both, or my probability of taking Spanish or French would be 52%. And remember, we knew the probability of both of them was 0 is because mutually exclusive, meaning they can't happen at the same time. So this one's a probability of a plague or a famine occurring. We want a probability of a plague plus the probability of a famine minus the probability of a plague and famine. So in this situation it tells us a plague is 39%. Notice I'm converting all these to decimal. A famine is 52, and both is 0.15, or 15%. So the probability of a plague or a famine in a certain part of the world is 76, or if it's helpful to think about it, that's 76%. Okay, this is our last section we're going to work on. Using Venn diagrams. I'm going to scroll down just a little bit. 1 second. Okay, I ended up changing my screen size. Thanks for being patient. So we have a Venn diagram that, depending on gender, can be if your ears are pierced. So probability of A is being a male, and probability of B is having your ears pierced. So male and ears pierced is 19. So I've used that number. Male without ears pierced is 71. Ears pierced but not male, which would mean they're female, is 81. I still need to put this 4 somewhere. So this 4 just goes outside. That means they're not male and they don't have their ears pierced. So probability of A means probability of being male. I have 178 total. Of my males, I have 19 and 71. Probability of A and B means male and ear pierced. Which is a little above 10%. A or B means I can add all 3 sections of my Venn diagram. So about 98% of the class is male or has their ears pierced. Not B is anything not in B. So this would be my 84 plus 4. Oh, sorry, that's a B. So not B is probably the one that's weirdest to think about. So that would be all of this part, and all of this part would be my not B. Four plus 71 divided by 178. 75 divided by 178. Um, 42% is not, 42% of people do not have their ears pierced. So we will continue to work on this in class. Make sure you come to class with your questions, and see you guys soon.